this question, we have, okay, so we have infinite charge line, finitely long charge line with the line density or linear density lambda. Lambda is Q over L, units, units coulomb per meter. Okay, lambda. So lambda is given as lambda. Okay, so line of charges. So my hypothetical surface I pick as a cylinder with length L, and radius R. Why did I do that? I need to find the electric field R distance away from the line. So this distance has to be R distance away from the line. That's where I want to find the electric field. If you look at this configuration radially upward, this is how you see that. You charge, you see like this, and then this is how the electric field lines go every direction. So three-dimensional radial view. Okay, so electric field lines. We are going to find the electric field at this point. That's what we're going to do. That is this point. Did you see that? Visualize three-dimensionally this picture, and then you'll see what we are going to do. Okay, now electric field. How do you now we have two definition for flux. First definition for flux is E times the area. Electric field times the area. Area of the cylinder, 2 pi RL. Definition 1 for the flux. This is the definition for the flux. And then the other thing comes from the Gauss law. Gauss law of flux is given as the charge enclosed over epsilon 0. Put them together. Charge enclosed. What is the charge enclosed? L times lambda. The length of the cylinder is L from here to here. Times lambda is the charge enclosed. So if you put this thing together, equation 1 and 2, 1 equals 2. So E times 2 pi RL is equal to L lambda. L cancel out, and you have E is equal to, oh, I have some epsilon 0 here. Epsilon 0. What? Lambda is the linear charge density of the infinite line charge. Density. That means amount of charge per unit length. Amount of charge per unit length. So the total charge is lambda times L, right? Amount of charge per unit length. The total charge enclosed inside the cylinder. Cylinder has length L, right? Cylinder length L, here, from here to here, L. The charge density of the line is lambda. So the total charge enclosed inside the cylinder is lambda times L, which is this here. Total charge, Q. And then what is the answer? 2 pi P. Oops. It should be not P. Sorry, I'm not functioning well, it seems. It should be Q. That makes you confused. Okay, so I do this all the time. I have to get myself checked. I use strong symbols, but in my mind I know it is Q, but I wrote a different. Okay, so this is what we need now. This is what we need now. Electric field at R distance away from the infinite line. Did you get it? Electric field at R distance away from the infinite line. Now look at the electric field. Everything else is constant except R. R is on the denominator. So when you go away from the infinite line, the electric field decreases rapidly because it's 1 over R function. Right? electric field decreases rapidly. So if you draw a graph, electric field versus R, magnitude of the electric field versus R, this is how it should look like. It's 1 over R function. 1 over X or 1 over R, 1 over the variable function. Not